to transport layer and so on, and meanwhile an acknowledgement will be sent. So MAC out, PHY out, and then PHY in, MAC in. So you can see that to just send one packet from a source to a destination, there are at least 20 to 25 events that are involved. Therefore, it gives you a great level of detail for the researcher to go in and study and to make changes and write their own protocols and algorithms. And finally, we look at some of the steps that may be involved in writing your own protocol. This is a fairly theoretical explanation of how you could do it, and practical examples, as we had as I had shown you earlier, is available in our website. So interested participants can see this file exchange. Here we have a number of projects with codes and documentation, and in case they have any questions, they can go to our help desk, which is there. Here again there are a number of articles related to different parts of the software, and again your questions can be asked and our support team is there to answer. So coming back to the presentation. So each protocol will have a protocol.c file and a protocol.h file. So let us look at the 802.11, for example, if you take. So this is the 802.11 project, and these are all the source files that are shipped with NetSim. So you can see that there are a number of files relating to the file layer, to the MAC frame, radios, and so on, rate adaptation. And here you will see the main 802.11.c file and 802.11.h file. All of this will be written as per the relevant IEEE standard. So you can see the data structures are all taken from the relevant sections in the standard. And you will first have to, if you're writing a totally new protocol, you will have to come in and write these data structures as per the standard. Otherwise, if you're making minor modifications to an existing standards based protocol already available in NetSim, then you can open any of this and make changes here. Then in 802.11.c you have 5 important functions, namely the init function, which initializes the simulation. Then you have the configure function. This takes in all the variables from the GUI or the model and populates the data structures. Then you have run, which is the main function which I will be explaining now. And then you have a metrics, which will write all the metrics, calculate, do all the calculations. And finally the finish function, which will complete the simulation and clear all the data structures. So to quickly look at the run function, we'll go into 802.11 run. So because 802 is a MAC and PHY layer protocol, you have events that are related to MAC and PHY, and out event is there whenever a packet is leaving a device, and in event occurs whenever a packet enters a device. So if you're writing your own protocol or you're making changes to NetSim's protocol, sometimes you have certain things in the protocol that occurs when transmission is done, and certain things that occurs when reception happens. So the transmit part of the protocol is written in the out events, while the receive part of the protocol is written in the in events. So if you look at 802 MAC out, the MAC out would be running the CSMA CA algorithm. Then this is used for carrier sensing. Then it would use the random backoff algorithm for CSMA CA backoff. Then you have RTS CTS, you have MAC aggregation, and so on. And when you look at the MAC in, for example, the MAC in does the transmission of the acknowledgement, or in some cases it will send the packet. So here is the send ACK event, or in some cases so for any packet that is received, on one side it sends an ACK, and in the device itself it sends it up to the network layer. So you will see the network in event that is there in MAC in. Next, going to PHY out, The physical layer is what does the actual RF transmission. So the phi out event is used to calculate the transmission time, how long does it take in the wireless medium. So this will involve calculating the data rate, there may be rate adaptation, number of other complexities. So here is where the entire transmit frame is done. Then if you take the phi in, where the packet is received, the phi in is where you have things like bit error rate, whether the packet is errored or not, what is the received power, then based on the received power it will check an SNR BR curve to see whether the packet is errored or not, and if the packet is collided or not, and based on that it is sent up to the MAC-in. So this is to give you an idea of the different events in 802.11 as an example. And with this we are completing our presentation on the discrete event simulation and a glimpse into the architecture in NetSim. And I'm happy to take any questions that you may all have, and I'd request you to write your questions in the chat window, and I'll try to answer as many questions as possible. In case I'm not able to, I'd be happy to send an answer by email to you. So please let us know if you have any questions. Okay, somebody wanted to see the queuing disciplines again. So this is where the queues are available. If you go to the router, and here you can see that you have, as we had explained earlier, FIFO, priority, round robin, WFQ. Yeah, the same thing is available in wireless also. We just open 802.11, and yes, in that it is 802.11e. So you can see the queuing in different kinds of queuing in WLAN as well. So you can set 802.11e enable, and then sorry, it's here. Yeah, so here once 802.11e is enabled, automatically it has different types of queuing based on which priority is set for the wireless transmission. How can we simulate scenarios for IoT? We have an IoT module that is available, which currently comprises of we'll just open an IoT scenario for you. So here are the different technologies that are there. You have internetworks, you have legacy networks which have Aloha, slotted Aloha, token ring, token bus, CSMS, CD. Then you have MANET, WANET, WiMAX, cellular networks, wireless sensor networks, and then you have Internet of Things. Then ZigBee, cognitive radio, and LTE advanced. So inside Internet of Things, you can go here. In this, you can set up a sensor network. This will help you in creating the sensor network. So to this sensor network, you must add a low-PAN gateway, and then you can connect the 6-low-PAN gateway to a router and then to the cloud or to your wired network. Then what will happen is the sensors will sense whatever is the phenomenon, and then data is sent, and you have an 802.15.4 based low-PAN gateway which moves it from IPv6 to IPv4 and then does the transmission. We are currently also working on RPL protocol. The existing 9.1 has all the MANET routing, and RPL is a new routing protocol that we are expecting to add in V10 of NetSim. I hope that answers the questions with regard to IoT. IoT is essentially just a sensor network connected to a cloud, and then 15.4 working. Yeah, so the cloud is the wired network. So if you change the link rate, the link capacity, and so on, it'll have the effect as a cloud. Then there's a question with regards to addition of new events in NetSim. New events can be added. It's a little complex, and just like you can see in 802.11, you have you have Mac out, Mac in, Phi out, Phi in, timer, and so on. You can add a different kind of event. So if you have a cross layer protocol or so on, you can add your event, or you can make changes inside this and change the way the event occurs itself. Then can you send real data into NetSim? Yes, we have. That is an emulator which we have, and that we would require multiple systems to demo that. So I can just tell you that our emulator is there in our website. So if you go under NetSim, you can see emulator. Here what you can do is you can interface NetSim to real hardware, and I can just show you in our manual about how it works. Yeah, so this is the emulator. So you can have a source, and then you can transmit that data from the source to the destination through a virtual network. And so real data will go through a virtual network, and this way you can check your own, you can check how your protocol, suppose you write a new protocol in NetSim, and you don't just want to simulate it, but you want to see in the real, how will it affect real applications. That can be done using the emulator. Trial version of NetSim, I'm sorry, we don't give any trial versions. We have all the features available in videos. We can give demos as and when required, but due to security constraints, we have stopped providing trial versions. I'm sorry about that. When will V10 of NetSim be launched? We are expecting it towards the end of this financial year, so around March, and we expect V10 to have support for 5G. So you will have D2D communication in NetSim. Then you'll have RPL protocol, and then we expect to add IEEE 1609 for vehicular ad hoc networks, as well as several other changes. So it's all under development, and we are expecting it to come out in March. And just prior to that, we'll be sending out emails with the different features. And there's a question how to write your own program for IoT application in health monitoring and health monitoring simulation. See, NetSim is what can I say? It is abstract to the actual sensing mechanism. So you can have an IoT. The IoT can be health, it can be temperature, it can be pressure, it can be velocity, it can be anything. So the sensing mechanism is separate from the network communication, and NetSim handles the network communication. So we have a sensor.c file in which if you want to make it behave in some different way and measure different things, you can do it. It's abstract as to what is happening above the network communication layer. It can be health, it can be anything. We just have an abstract sensor. So you can set whatever you want on that. Can we get a recorded session? Yeah, in about a week's time, we will be uploading this onto YouTube. And once we have YouTube, we will, we can just send you a mail and you can look at it. Then does version 9 of LT have LT advanced? Yes, we have LT and LT advanced. So here you can see we have LT advanced. LT advanced, we basically have relays. Then we have carrier aggregation, MIMO, multiple antennas, and so on. And in the help, if you would like to see, we have so here is the LT advanced help. Can we incorporate our own protocols? Yeah, in cognitive radio 802.22 is open. So, but one thing that we would like to tell our users is that if you want to write your own protocol or your own code, then you should be fairly well versed in C, and you should know some basics of data structures, and using that you can write your own code, modify the code, and link your own code and see the performance of that. Can we simulate real-time sensors data? Yes, you can, and the way to do that is that you can't, you'll have to get the output of a sensor into a text file, and then you can make that text file, you can input that text file into NetSim. So you can have some sensor sensing that, and once it completes, it writes a text file. That text file can become the input, or you can have many such text files, one maybe for each sensor or multiple text files for each sensor, and that will then be sent to the sink. So it's virtually as if the real sensor is sending, but it is interfaced through a file. No, we don't have any free of cost version. This is a commercial software, and educational institutions can buy it at discounted academic prices. But there is nothing that is free of cost that is there from our end. What is the cost? Well, you need to, if you want the discounted version, then we ask that we get an official email from a faculty member or a university official from their official email ID. If they send us a mail asking us for the pricing, then we have different channel partners in different parts of India and outside. So depending on where you're writing from, the appropriate channel partner will contact you and let you know the pricing for that. So our email addresses, you can write to us at sales@tetcos.com for any commercial questions, and you can write to us at support@tetcos.com for any technical questions, and then you can, our local channel partner is available in this site, so whoever is the nearest to you can be seen there. You can also look at our help desk and you can write in technical questions for existing customers from there. So I think with that we will be ending this webinar. Thank you all for your time, and please feel free to write to us, and we'd be happy to hear from you and answer any questions that you may have.